Hello and welcome to the Operational Edge, a podcast for tinkerers and thinkerers, where we talk about different technological topics focused on the industrial automation space. I am Marsha Wisely, and I'm here with my co-host David Lee. And today, in episode 5, we will be talking about some different alarm strategies and how alarming really impacts operations and the overall ecosystem in a manufacturing facility. So, hi, David. How are things going?
Good. Yourself?
Doing well. All right. Well, I spent my career working in industrial automation, but alarm management was just really a small piece of this. And I know that it's an area that you've kind of specialized in. So when it comes to alarm strategies, can you talk about a little bit about the tools that are available for folks? I've heard the terms alarm management, alarm rationalization. Can you just talk a little bit about kind of the basics? Let's assume that I don't know anything.
I think it's a good place to start. I think people do confuse somewhat those two terms that you mentioned, alarm management and alarm rationalization. Alarm management really is the big picture. It is making sure that your alarms are effective, or your alarm systems are effective, whereas alarm rationalization is just a piece of that. So if, for example, you look at the ISA 18.2 lifecycle model for alarm management, rationalization is just a piece of that. Whereas if you're really trying to look at making the best use of your alarms for your operators, is looking at the bigger picture, looking at things like maybe your alarm help or your alarm presentation, shelving, and all those different things that really help you manage the system, not just be a part of it and get and make sure you have the right KPIs that the standards recommend in terms of rationalization results. So I think there's a key differentiator that we have to be thinking about is don't think small. Don't just think rationalization is the end goal. It's alarm management, which is the end goal.
Okay. Yeah, you mentioned some different tools. So like alarm help, I've seen that deployed in control systems where maybe like when you click on an alarm, an operator is getting like a notification about what does this mean or what does this do. I guess is like, and I've seen that deployed pretty regularly in my experience. I guess what tools would you say, or what of these kind of, I'm going to say like alarm strategies or alarm
Mhm.
management philosophies are more commonly deployed, and which would you say are more like advanced, right? What's the low hanging fruit? What is going to take maybe a little bit more thought to go into?
I think, unfortunately, we see a big range. I mean, there's some very poor systems that have alarms, but obviously they're not effective. And in those systems, basically it's an alarm gets triggered, you get a notification. If you're lucky, you get a decent message in the alarm banner, so you know actually what it is, or have a good start to identifying what it is. The next step of that is really sort of, if the operator doesn't know what that alarm message means or needs more help, is how do we provide that to them? So that's where alarm help comes in. Typically, to support that, you need to firstly have and rationalize your alarms to understand the causes, consequences, corrective action, so you can document them. And then you need a tool to a repository for that information. So you don't have a master alarm database, for example, where do you keep that and where do you reference from your alarm help? So the alarm help is the tip of the iceberg. It's good information, but it needs a supporting structure and information to actually populate it effectively.
And that master alarm database, that's going to be because some of the control systems like will have their own individual alarm databases. But when you say master alarm database, what exactly does that mean?
Yeah, you can do it within the control system, but then you have to assign it to, maybe to a tag and embed the information inside that tag where the alarm's been generated. You have a third-party piece of software. You can have an offline master alarm database that you connect to your DCS and bring that information from. And that's typically a more effective way. And in fact, the ISA standard mandates that you have to have a master alarm database. So, starting there and having that information is probably the best way. To implement it in code, very difficult. You got to go into every single piece of alarm generating logic to add that information and maintain it. It'd be very difficult. So I always prefer to have some sort of offline system, just maybe a spreadsheet or an Access database that you can put on a PC, but something that's actually interactive with your DCS that you can get that information from.
Yeah, and I can only imagine, especially as the industry moves more and more towards modular style manufacturing, where we have skids and these different pieces of equipment, where sometimes, maybe sometimes your IO is actually coming into the control system and everything's in the same happy database. But a lot of times you end up with logic living, inside of a PLC that's in a skid, and maybe that's coming up to a either higher level PLC or DCS, right? Distributed control system. And so in that case, then a master alarm database also serves to make sure that you actually understand all of the alarms that are happening in the facility and your whole
Mhm.
strategy. Is that right?
Yeah, and as you said, that could get even more complex with typical SCADA systems or PLCs that are brought into a DCS, and they maybe just bring back a discrete point. You have an alarm, but that's all you know. It's a high level on the tank or it's a high temperature, but you've no idea what the context of that is. What are the settings, what's the priority? Maybe you have that in the DCS, but certainly it's more difficult to grab that information down from the PLC level.
Well, and, you know, thinking about these alarm strategies, continuous process when you're up in your steady state, I'm sure that that's, ideally we can get the alarms to nearly zero.
Mhm.
But there are certainly, when we're changing states, when we're starting up, as an example, I have seen alarm floods where we just sort of aren't even paying attention to the alarms because we're in the process of starting up. And that's not the way that the alarms were rationalized or considered really during those sort of dynamic states. Are there tools that help during those kind of transitionary periods to make sure that we aren't flooding operators and really giving them the right information at the right time? Because those are really overwhelming times to be an operator, really.
Yeah, and you're right. I mean, 10, 15 years ago, maybe even longer, alarm rationalization was static alarm rationalization. People thought about steady state, and they would do alarming based on those conditions. And then they found, well, we're not fixing the problem. And as you say, we're still getting alarm floods. We're still getting, maybe a compressor goes down and we get 50 different vibration alarms and temperature alarms going off. In normal conditions, those don't come in, so they don't get rationalized out. So really thinking about more of a system approach to alarming. So looking at a compressor and saying, okay, what states does this compressor have? And then applying, whether it's state-based, dynamic or conditional alarming around that. That can certainly help reduce those alarm floods. Looking at the tools that can do that, again, there are platforms that can do that offline with state engines that can drive the states and eclipse or shelve or do whatever they do with the alarms to take them out of service during those periods. You can do it in logic. You can use conditional alarming, but the coding gets very complex. And again, not just trying to get the coding right first time, which is an engineering challenge, but then how do you view that? If you have a platform that can visualize the states, visualize the enabled alarms and disabled alarms, that's great. But if you have to build those HMI graphics to look at your conditional alarming, that's another extensive piece of work. So yeah, there are tools. There's
Absolutely.
better ways of doing it. It just depends on how much you want to invest in doing that. But it's certainly, I believe, a technique that has to be considered whenever you're doing your alarm rationalization.
And I think about the next engineer, let's
Mhm.
say, too, right? You do all this conditional alarming, depending on, especially if it's inside of a database and we're referencing and cross-referencing and building this kind of like spider web of references,
Mhm.
that can be difficult to trace down eventually. It's not spaghetti code per se, but it is, a network of references that you have to figure out what's referencing what,
Mhm.
versus bringing everything into one place. I imagine that it would be easier to get a clear picture of like, okay, what's happening during startup? What's happening, if my compressor is offline? What's happening under these different conditions or states, or whatever trigger is causing you to have a different alarm strategy?
I think if we maybe look at the batch well, they have a
Hmm.
different process or physical model, the way they look at equipment. We've been
Hmm.
doing conditional alarming in batch for many, many years. We turn alarms off when it reaches certain parts of the process and so on. So the process of doing that is well understood for batch. If you start looking at the continuous and say, well, we're different. Well, are we so much different? you can still split equipment up into equipment modules. So, for a distillation column, you may say, okay, well, if I have the circulation loop, that's an equipment module. I've got equipment associated with that. I have alarms associated with that. If I now treat that as an equipment module and maybe use a manual phase or use some other logic that we've used in batch, then we can drive sort of a state-based model within the DCS based on that equipment module and phases. So there are some techniques that can help you do that within the DCS if you have a batch system, for example, or even a sequence system, something that can drive that state engine. But again, all you're going to be seeing in the equipment module faceplate may be some simple true-false type logic rather than the full schematic of what's going on at that point, or SFC at that point. So again, looking at what is a tool that can really drive visualization as well as control, I think makes a lot of sense. There's been a lot of pushback over the years to say, well, we don't really want a third-party system writing down to our DCS. And I think technology's evolved, that we're seeing much more robust linkages and seeing watchdog timers and things to make sure that those processes are working correctly. So I think it's better than it ever has been. So I don't think we should be as afraid as we have been in the past. But again, be cautious and build and make sure you do it properly. But I think it's a good solution today.
Yeah, when you and I were at the ISA conference, the International Society of Automation, one of the talks that I heard was talking about digital transformation, and you have to transform. If you want to adopt these technologies, you have to transform your thinking, and some of that is accepting that the cybersecurity that you're putting in place, right, all the protections and everything, and the software and everything that you understand and all the testing that goes in makes it okay for something like your alarm strategy to be coming from a third-party system. But again, that's changing your philosophies, that's changing the way that you operate, and so it certainly takes a different kind of effort. But it sounds like it can add a lot of value in terms of bringing everything together and making sure that your alarm strategy is cohesive.
Yeah, and cost has come down a lot too. Buying extra servers is not as cost prohibitive as it used to be. You have to buy another controller because the additional workload or the additional load associated with conditional logic. Controllers are as expensive too, so you have to weigh the pros and cons.
So speaking of cost, these kinds of projects, when we're looking at them, I'm sure that the cost is going to be associated with how the process. I think about a highly critical or a highly safety impactful process. I'm sure the alarm strategy is going to take a lot more energy and effort and engineering to do successfully in a way that's really going to support operations in the right way versus something that's relatively simple. Relatively simple alarming probably does the job. How do you look at justifying a project, whether it's something small or something large, as a consultant to help these projects move forward for end users that are looking to have a more robust alarm strategy?
I think it comes down to two things. One obviously is that there is a workload impact of alarms. If we have the operators doing a lot more alarm management, then they're not being able to be proactive perhaps in the process. They're being reactive, so wait for alarms to come in before they take action. So there's a workload impact. There's obviously always the safety impact, right? I mean, if you have a bad alarm system, you may miss something. So there's always that fear or that lost opportunity from the process that you may get. So there's a real return on investment in terms of that lost opportunity. But a lot of cases, it's like, well, why wouldn't you do it? This just seems a no-brainer. You need to give the operators the appropriate information at the time to do their jobs. And if we don't do that, then we're setting ourselves up for failure. So I don't really think it's a question of necessarily justifying it. We all know it's the right thing to do. There is significant cost in doing it, but that's just part of doing business almost. You have to program the DCS. There's a cost associated with that. You don't deny that you have to do it. It should still be that sort of base work that you have to do. But again, if you think about it from the very beginning, if you really plan in not just your alarm management, but even thinking about, okay, if I look at my system or my equipment, and again, take it back to that equipment module or unit module level, So, okay, well, let me think about not just in terms of alarms, but maybe in terms of HMI design. If I have equipment modules, I want to make sure they're on a level 3 graphic, for example. If I'm doing state-based control or procedural automation, the same sort of foundational objects or equipment modules could be used for that. So if you start getting into it, split your P&IDs up into these equipment modules, and you sort of get ahead of the game. Try and build in some efficiencies in the engineering process to make it more cost effective.
Yeah, I think, it's interesting because a lot of these technologies really address like one particular pain, which I think is very reasonable because, it allows you to take a very targeted approach to solving a problem. I do think from the industrial automation engineer's perspective, right, thinking about the person who's managing the DCS or the PLC on site, sometimes it feels like there are just so many facets of what needs to be done for kind of this industrial automation space, and making sure that you are considering all of the different pieces can be a challenge at times. Coming from a training and simulation perspective, like, as much as it feels like a no-brainer for me, I can understand why somebody might not consider that as part of their planning process, or not consider it until they get later into the project, because there is a lot to think about for alarm strategies and that sort of thing. Do you see any challenges like incorporating, because this is something we certainly experience in the simulation world, is that like trying to do everything as part of like a greenfield project, right? The first time that we're deploying your control system, trying to do everything is kind of hard because we don't really know for sure how the system is going to run. We don't exactly, you can do as much testing as you want, but eventually you're going to need to see the real system to really make enhancements in simulation. Do you see anything similar in the alarm space, to say like sometimes you might start smaller and just know that your strategy is going to develop over time, or what does that look like?
I think it's an approach you can take. A lot of people do. They'll do static rationalization first. And say, okay, we understand the process, we have the P&IDs, we can do that. So they'll set off down, even on a brownfield project, we'll do that. And so we'll do dynamics later. We understand, the first bit, we have to get our alarm rates under control. So we'll fix that. But it's really inefficient in doing that, and you can miss a lot. So if you're going through rationalization, you're going through every tag and you're making sure you understand, the different alarm points and priorities and all those things. It's not a lot extra to start putting that in the framework of, well, when is it appropriate? So you're not just asking, set points and all those things, but asking that question, when. So to get that answered very early on as you're doing the process of rationalization can help. Now, whether you implement that straight away, you can say, well, okay, I'm going to rationalize with dynamics in mind, but I may not actually implement dynamics until further on down the line. That's okay. Right? You've already got the information. Maybe you can get experience and tune that. But to not do them together really is not as effective or cost effective, first off. And as you rightly say, once you get running, alarm set points will change, maybe equipment will change, lineups, who knows? It may impact the dynamics more so than it would do the static piece. So a staged approach to implementation may be sensible, but not necessarily rationalization.
So do you think the state-based approach helps with that? Some of the reason that it's hard to do early implementation with simulation is because there's so many dynamics happening all the time. With, if you take a more state-based approach to your alarm strategy, it seems like that's all part of your control strategy that you're developing at the same time. And so it feels like it could nestle in pretty well if you know that that's part of your procedure.
Yeah, it may also help determine how you're going to configure your tag database. If you are thinking in terms of equipment modules, well, maybe that's the way you lay them out. You split them up into that, and you build that into your hierarchy in your tag database. So it could influence your, just your base configuration. So understand what that's going to look like, may help. It also help towards designing the HMI. I mean, alarm management is a big piece of that puzzle. So understanding, if you say, okay, my level 1 has to have all my critical alarms on it, well, you need to know what those critical alarms are and when they're going to be appropriate. So again, getting that really tied down to start with helps you be more effective in other aspects of the project.
Alarms are certainly important from a lot of different perspectives, but yeah, really taking that and putting your operator hat on, right, and thinking about their whole experience ties into a lot of the work that you do at UCDS, it seems like, right? Really taking that perspective and considering what is the impact, whether it's the operator's environment or how they're visualizing things. It's really part of a whole picture, right? The operator doesn't care about the alarms. The operator cares about operating effectively and having a smooth and successful day, right? So being able to really think about all of those pieces helps ensure that they can be as effective as they need to be.
But an alarm is just one piece of that. I mean, once you get an alarm, you're already sort of heading to the ditches, right? So if you start thinking about what are the things that's going to help me proactively respond to off normal conditions, so it's not going to be alarm, maybe it's an alert or a notification or some other tool that you're going to generate for the operator. Now that sort of plays into it too. And as you start talking through rationalization, you say, well, I'd really like to know at 80% level, I don't want to wait till I get 90% alarm. So what do I need to do there to provide the operator with a notification or some other tool? So again, rationalization is just a piece of that to help you understand maybe the process demands for some of those responses. It's just that thoughtful step-by-step process of going through all the tags and again understanding the process and how it works and where are the boundaries that you need to watch out for.
So when you're doing alarm rationalization and alarm management, like a lot of this industrial automation space, right? This is going to be applicable across industries. Are there any challenges that you run into in specific industries? The one that kind of comes to my mind would be like in a validated space. We talked about that third party sort of system communicating with the DCS, especially like a dynamic alarm. Seems like it could potentially be, what do I want to say? Perhaps a complication in terms of trying to figure out how you were going to go through your validation process. So just kind of curious, like, do you run into those kinds of challenges?
Yeah, that's true across really all industries. I mean, you're going to start getting license alarm limits and things like that that are going to be imposed on the project. You may not agree it's an alarm, but it's required for your license, from your process license. Or same with pharma and life sciences. There's going to be certain alarms in there that are not even negotiable. I mean, that's what it is, right? So you have to have that in there, and that's part of the process. Now, whether you set that as high priority or low priority or whatever it might be, that's a discussion you have to have. But there's going to be some alarms that they say this is non-negotiable, and that's fine.
With those non-negotiable alarms, do you get caught in a spot where it would ideally be something that gets turned off like during startup or something like that, and we can't because it is this sort of protected, like it's for your licensure, it's for, it's EPA regulated, it's regulated by someone.
Mhm.
So we basically just get that tiny flood.
Yeah,
That's what I'll call it, right? Every single time, because of some of those regulations.
Yeah, and that's there's some alarms that you won't touch during dynamics. If you have a critical level alarm, critical priority alarm, you're not going to shelve that. That's going to stay active under any condition. So it's the same with pharma or other industries, that those are not going to be touched by shelving or dynamics. And unfortunately, the consequence is that you may get some floods, but that's by design. I mean, you're saying
Right.
we need it. I think some of the challenges too is, as we look into the future, and I talked about AI and the impact of that in alarm. That's generating a lot more alarms that people keep saying, well, you need these. And especially in the reliability field, people say, well, if the vibration goes to this, it needs to be a critical alarm or whatever. And it's being generated by maybe a reliability package. Again, those are maybe non-negotiable. We hope not.
Mm-hmm.
But the impact of those sort of technologies generating even more alarms that we have to consider is maybe good or bad. We've got more information, but is the information really valuable?
Yeah, I think about that too, and some of that comes back to having, I think, that full picture, right? Something like a high vibration alarm. I would ask the question, is this the only piece of equipment, right? That if it's a continuous process, is this the only one, or do we have an A, B, and a C?
Mm-hmm.
If we're getting close, right, rather than having this critical alarm and then different things are happening, is that an opportunity from a control perspective to start triggering, maybe requesting that pump, whether it's a compressor or whatever that might be, that comes online so that we can avoid can we avoid some of those alarms, right? It's a good conversation to have, and maybe the critical alarm deserves to be there, but then the alarm strategy kind of turns into a control strategy to say, how do we avoid
Mm-hmm.
these critical alarms from coming into play? Rather than putting the onus on the operator, how do we take the onus off the operator? Because ultimately that's kind of where the alarm comes in, is that it's going to trigger a human action of some sort, or it's alerting you to some other actions that are being taken. But if we can think about our control strategy in a way that helps to identify when we're on that trajectory and change paths,
Mm-hmm.
I would think that would be an opportunity to another way to avoid those alarm floods.
Yeah. And like 2 out of 3 voting alarms, things like that. Maybe another strategy, not strictly dynamics, maybe more conditional type alarming. Maybe we do a group alarm, we do some other simple logic type stuff for the alarms. But it's a good discussion to have when you do the rationalization. You're looking, I've got 3 temperature probes, I have high highs on each one of them. But if one of them goes off, it could be a bad sensor. How do we handle that? So the rationalization process should take care of how you manage that particular alarm. Maybe one gives you a low alarm, a high, or 2 of them gives you a high. Whatever it might be. But you have those discussions, right?
Yeah, and looking at, I've also experienced and seen people look at like root cause type alarming, right? The pump is already an alarm. Do we really need to also know that we're low flow in front of the alarm and that the pressure is doing something unexpected, right? Looking at those higher levels and saying like, okay, this one supersedes all of these others. We already know that something is going on. If the equipment is going off, maybe we don't send you all of the sort of what would be indication alarms when we already know that there's a failure.
If you use dynamics, well, also, again, simple conditional alarming, but also give the operator the ability to turn that alarm off if it's bad. We often see, for example, shelving not being used at all on a site, or not giving the operator the ability to shelve. So, making sure that, again, the alarm management piece, the whole holistic view of the alarm management system, enables them to maybe head off any bad alarms or bad PVs that could trigger a trip or a sequence of alarms.
Do you see very often, as part of a bigger alarm management strategy, companies deploying analytics on things like how often are operators, shelving alarms, or doing that kind of evaluation to determine if an alarm is constantly shelved, right? Really looking at the whys, and I guess, what does that look like when you're maybe going in after a project, right? How would you approach, maybe that's the core of the question, is when you're going in after a project, what is the first step? Like, how do you really sit down with an end user and help them determine what their strategy should look like?
Yeah, and that's really sort of the monitoring piece, right? Once you finish the project, then that's when your KPIs will start being tracked, and making sure your alarm rates aren't changing, the flood rates are not changing, but also number of shelved alarms, number of stale alarms, all those different KPIs. As long as you keep tracking those, you should be able to see where you are at day one, and then see if it deteriorates over time, or give you opportunity for sort of that bad actor resolution type approach, where you're looking at what are my 10 bad alarms this week, because if you've done a good job on rationalization, it's likely that most of those are going to be instrument related. So you can start getting into that continuous improvement type process to make sure your system doesn't continue to deteriorate. And that's easy to do. I mean, you get an incident, you slap another alarm on. You keep doing that. Your alarm rates are going to start going up, and you're going to see worse floods. So again, having that continuous improvement, that monitoring piece that's defined in the lifecycle model to make sure that you don't fall out of where you want to be.
So, and I think you had mentioned this earlier, but there are some different standards and references that people can use to make sure that they're deploying what are considered to be the best practices in this kind of alarm management space, right? So what are those standards?
Yeah, so the ISA standard, ISA 18.2, is seen as really the sort of de facto standard that we have out there today. There's the IEC equivalent 62682. Okay, I was going to get that number wrong. Get confused with the cyber number. Anyway, there's also the IEC alarm management standard that sort of matches the ISA one. So those are the two key ones. People always say, well, the IEC is the international version, but ISA is also an international standard, so you can use that worldwide. There's some other guidelines like the EMEA 191 guideline, which again is more of helps the user understand the process of applying alarm management. So that those are two good documents to use. And when you start looking at your alarm management system, you really need that alarm philosophy as part of your definition of what your alarm system should be doing, how it's managed, how you're going to do all the life cycle steps and all those things. So it's really key to have that life cycle, a big part, have that philosophy developed very early on to, again, lay the foundations of what your system expectations are. And then again, if you look at 18.2 Technical Report 1, it gives you a framework for a philosophy document. So there's some good guidance out there on what that should contain and what it should discuss.
Yeah, and there are certainly people that specialize in this area as well. So plug for David, his consulting group does do work in this space. But there are specialists, because we talked about this a little bit in the follow-up to the ISA conference as well, is that there's just so much scope to cover that being a specialist in all of these different things would be so challenging. As industrial automation professionals, we've got cybersecurity, we've got alarms, we've got, all of the other considerations for operational effectiveness. We've got training, we've got, on and on and on and on. So knowing that there are specialists, out there that can help, whether or not it's execution, philosophy, all of those different pieces, right? Just to help make sure that you're on the right path, whether you want to self-deploy or bring somebody in, right?
It's quite often the case where a company identifies as an alarm management issue. So they'll say to maybe the newest chemical engineer or control engineer, they're going to fix their alarm problem, and that's his project, right? First off, that's not necessarily very effective. They don't have the knowledge as of themselves. They don't have to get input from operations and everything else. So it's not a project that somebody can just run on their own. But it takes a lot of time. You could almost have a full-time person just doing that, getting away from their control work. And so whereas a lot of senior management think of it as just, well, you can just do that on the side. And it really needs to be concentrated on. The other piece that we find is important is not just thinking about the technology, but really understanding the process. And you see companies using people that, again, not necessarily understand the process as much as the technology that they're using. So you'll get a control engineer who absolutely knows the DCS and knows all the configuration, the control strategies and everything else. But if you have to ask them how a big compressor or something like that works, might not necessarily have the knowledge to say, well, we need to do this alarm, and this is the important piece of the alarm. So it's important to have people that have a process knowledge involved in the actual alarm rationalization. There's also some methodologies where you can look at using consultants such as us in different ways. I mean, people use us for chairing meetings. So if you need somebody just to be the chair that coordinates your alarm management meetings and rationalization meetings, that's fine. It's very time consuming and resource hungry for the client. But it's like us can take that information offline and start doing some pre-work to actually reduce that resource burden for the client. So again, different ways of doing it, different ways that you can use either consultants or in-house people, but there are different ways, and depending on what you have in terms of A, the problem, and then B, the resources to fix it. There's just different types of solutions, and then Once you understand the problem, then maybe look at technology to help you meet that need. As you said, do we have a master alarm database? Well, we don't. So we need to look at a piece of technology. So again, it's a process, right? It's not an easy one to fix overnight.
Yeah. Well, and it's good to know that there's support for those folks that are looking to run those kinds of projects and really provide the best information with respect to their alarming. So, although the process, you mentioned that the technology is important, but the process is that much more important. But I'm gonna pick a little. Technology wise, there's all kinds of solutions out there. We talked a little bit about, it can be a master database, it can be in the DCS, David's preference, right? Taking off our agnostic hats because we're people and we have preferences. So, from your experience, these different products are going to provide different values for different situations, but just kind of broad strokes across the board, are there any platforms or any solutions that really have kind of shined through in the work that you've done and provided a differentiated value?
The vendors are getting smarter, so their inbuilt tools are getting better. Certainly in terms of things like KPI reporting and doing some sort of advanced alarm management. I still personally think that Emerson's Agile Ops is probably the leader in terms of technology, especially with its capabilities to do state-based alarming. There's integration to various forms. It's not just Emerson's; it integrates to others. So I personally favour that one, but I also admit that I also used to work for Emerson. So, but hopefully,
Yeah, we've
hopefully
got to put a little disclaimer on that.
but my personal perspective, not working for Emerson anymore, I still believe that is the best platform out there.
Yeah, I mean, it helps that it came from a place of being an agnostic company before it was acquired, and so it does have a lot of those capabilities, which is helpful, especially when you're looking for that. If you're looking for that master alarm database, certainly a lot of capability.
Yeah.
And then sort of a different take on technology, looking forward, right? We've talked a little bit about like where we've come from, which was a lot of static alarming. We've gotten into some of the more conditional and state-based and that sort of alarming. Where do you think this is going in the future? And do you see, the question of the day is always, how does AI fit into this picture, or does it fit into this picture?
If you use AI to take alarm data and then tune your alarm management system, I think there's obviously an application there. It's in real time. It's looking at alarm rates, maybe looking at alarm limits, even priorities, and saying, okay, well, this is not appropriate. It needs to be tuned a little better. Whether it's 96 or it's 95 or whatever it might be. I think there's an application there. The other side of it is AI can also generate a lot of alarms. It could in itself say, okay, well, yeah, that compressor needs an extra alarm, maybe. So left uncontrolled, it could actually make the situation worse. But I do think there's applications, and again, maybe even reducing the burden on people to do dynamic rationalization, because the system can take data and generate its own strategies. So I'm sure that'll be in some people's minds out there in the marketplace, but I'm not smart enough to develop something like that.
I will say this I'll say this all day. I see AI very often as, at least right now, right? Who knows where we'll be in the future, but today AI is the best intern you've ever had. So kind of going back to that, like, it takes some experience to really develop an advanced alarm strategy for a facility and make sure that it works for what the facility really needs, because there's a lot of angles that we're considering. So to your point, like something like tuning, it's like, please look at this huge amount of data and determine if we could do slightly better by moving this point slightly, right? Perfect. I think, a young engineer could look at that and solve that problem. And so when I'm thinking about different applications in the scopes of work that I am in, that's sort of where I look. And so to that end, like, should an intern be defining a bunch of new alarms for me? Maybe not. And so from my perspective, it's good to know that that's my philosophy continues to kind of work, which is there are great applications, but to me it's, is there enough data written down and collected in a strategic way to give AI the right direction to walk in? If not, then maybe we can figure out how to put the data together and give them the right direction, but maybe not today.
Yeah. I mean, the data's certainly there. Right? I mean, we capture every alarm, we capture every process variable over time. I mean, everybody has historians. So the raw data is there. Whether we get confident enough where we can make that closed loop where AI can detect and adjust might take some some getting there. But certainly in terms of like a machine learning tool where it can make recommendations to say, yeah, consider changing this set point and this is maybe more uptime because of it or whatever it might be. I think that might be the first step. It's sort of still having a human in the loop to approve that.
Make the suggestion and then have a human approve it.
Yeah, but and in a way, we sort of do that with regulatory control. We have ones that self-tune in loops and things like that. So we've sort of accepted that, or even APC. We've sort of accepted that intervention by the system.
Mm-hmm.
Not sure where they're yet with alarms, but then maybe
especially those very highly critical ones.
Yeah, I mean, we just start adjusting your SIS system with AI. I mean,
yeah, especially if AI is just told to reduce the number of alarms, I'm sure they could. It may not have the effects that you want, though.
Right.
Well, thank you so much for your insight, David. This has been really informational for me. It's a big scope. It's so important to what we do, and I really appreciate the conversation.
So, awesome.
Well, that's all that we have for you today for the Operational Edge, and we will see you next month. Thanks so much for listening.